Hello everyone, welcome to Dakshana e-classroom program. So I hope everyone did their best in this exam FST 20 paper 1. So today I'm going to discuss about the solution of this paper for part physics. So let's start with this. Let's read the problem, first problem number 1. So here read the problem carefully actually. So 4 trials of Young's double slit experiment are conducted and you are given lambda blue is 450 nanometer and lambda red is 700 nanometer. So this is information. And trial 1 it's mentioned blue light, so it's lambda blue is used and 2 slits, so his small d is given as 400 micrometer and form an interference pattern on the screen, that is capital D is 4 meter away. So this is the setup for trial 1. Trial 2, the setup looks like this. In a second trial, red light passes. So here first it's red light is used and then passes through the same slit and fall on the same screen. So D is also same 400 micrometer and capital D is 4 meter. And trial number 3, third trial performed with red light and on the same screen but with a so it's red light same screen on the same screen but with the slits. Okay, so here D is 800 micrometer but capital D is 4 meter same. And the fourth trial is performed with the red light, so this is also with red light with the slits, okay, 800 micrometer apart and screen at 8 meters. So capital D is 8 meters. So these are 4 setups given actually, and now what it is asking, let's talk about that. So if the angle between the first maxima and central maxima in each case is theta 1, theta 2, theta 3. So theta is what? Basically it's angular fringe width that we measure as lambda by small t. Now it's theta 1, theta 2 and theta 3, theta 4 corresponding to each of these trials, and this y respectively, and the distance between central maxima and first maxima is y1, y2, y3 and so on, y4 respectively. Then so y is basically our beta and that is lambda capital D by small d. So then corresponding y1, y2, y3 so on. So then we are asked to find the relation between these things. So we can write easily. First we need to write, so what is theta 1? Theta 1 is equal to lambda divided by small d. Lambda is blue, 450 divided by, I am not considering the unit because rest things unit will be same for every case, only let's talk about the magnitude. So this is 450 divided by small d, that is given as 400. Okay, so theta 2 is equal to lambda r 700 divided by it's 400. Theta 3 is given as lambda 700 divided by 800 and theta 4 is given as same 700 divided by 800. So you can see easily these two are equal. This is the maximum and it's less than 1, it's greater than 1. So definitely this quantity will be this is maximum, then after that this and these two equal. So what is the option? So here you can write theta 2 greater than theta 1 greater than theta 3 equal to theta 4, and this option matches with it's C. So this is correct option. Similarly for y1 we can talk about y1 is what? Lambda capital D by small d. So here you can write this is theta multiplied by d, right? And this is the relation. So here theta 1, so y1 is theta 1 into d is how much? D is 4 meter. Y2 is how much? Y2 is theta 2 multiplied by again 4 meter, and y3 is theta 3 multiplied by 4 meter, and y4 is theta 4 multiplied by 8 meter. These theta 3, theta 4 are equal, but here this is multiplied by 8 multiplied by, so definitely y3 is greater than y4 is greater than y3. We got this relation, and here theta 1 it's like 4 and this multiply, so I can get basically theta 1 sorry y1 will be proportional to around 450, and because 4 and 400, so I'm get 4.5 something proportional, and y2 is theta 2, so 700 divided by, so it will be like y2 is something proportional to 7, and y4 if I just look at it, then y3 and y4, so y3 this divided by, okay, this divided by 800, so then it will be like 3.5, so y3 will be proportional to 3.5 something, so then we can get y2 is maximum, and then here another thing, y4 is multiplied by, so y4 is actually 7, so y2 equal to y4 greater than y1 greater than y3, so that is the, so y2 equal to y4 greater than y1 and greater than y that's equal to, okay, that's greater than y3, so this here option greater than y3 and here option matches, so y this is 4 equal to y2 greater than y1 greater than y3, and this matches with your option D. So this is about problem 1. I hope it's clear with everyone. Let's talk about question 2. Two objects of same mass fall from the same height of two smooth fixed inclined plane with different angle. When they reach the bottom, they should have same. So here we are given with the, this is the one condition theta 1, and let's say it's given as alpha 1, and in another situation it's slanted more, so this is given as alpha 2, and you can see easily the heights of these two is same, right? So and both are smooth surface, it's mentioned, and one two objects of same mass fall from the same height of the two smooth inclined plane with different angles, so angles are only different. When they reach the bottom, they should have same. So see, the kinetic energy, they are released from same object on smooth, so there is no loss of energy is taking place. So the kinetic energy reaching here will be equal to the, so kinetic energy is equal to simply change in potential energy, that is equal to mgl. So here definitely kinetic energy k1 will be equal to k2, that's correct. And kinetic energy is equal, so I can write speed will be also equal, correct. So A option kinetic energy equal, that's A is correct. B option impulse of normal reaction by the inclined plane. So what about impulse actually is should be same. All right, so actually if you look at the impulse, then the change in momentum along the incline, because impulse is a vector quantity and that will be like at different angles, so it will not be definitely equal. Momentum here, because speeds are equal but momentum is again a vector quantity, so speed is equal, magnitude of momentum will be equal but momentum will not be equal, so B is also not right and C is also not right. And the D, the horizontal component of their momentum, so definitely horizontal component will be also not equal, so only A is the correct option. This is, I think, like straightforward, just look at it, think about it. Okay, consider problem number 3. So consider the circuit shown in the figure. The switch is closed for t less than 0. So let me first draw this circuit. So here the circuit is, this is a battery, one resistor R, an inductor, resistor, and then again one resistor. Here we have switch, which is a resistor, and this is simply connected, and here we have resistor and inductor. So this is the system given, and its EMF V, resistance R, it's given as R1 is equal to R, and R here things are not visible clearly, which is R1 R2. Let me just check it, which is R1 R2. Okay, so problem number 3 here. So this is the circuit given, and R1, R, R2, R, R4, 2R, R3 also 2R, and L1, L2, 2 inductors, and this is the situation. So for t less than 0, switch was closed. So when switch is closed, and that too for a long time, then this is the situation. Then we know actually how inductor behave. Inductor will be like behaving just like a wire, is it? So in this situation, in that situation, the circuit will have these two resistors in parallel, and it will be equal to simply 1 by 2R, 1 by 2R. It will be simply R plus R, so it will be 2R, and then 2R in parallel, so it will be like total R and plus R. So the current here I will be equal to E divided by 2R. And because this current will be dividing equally, so here it's like I by 2, and it's also I by 2, and here again it's will be dividing, so I by 4, I by 4, and here also it will be I by 4. So that will be the current in each part of the circuit for the situation t less than 0. Okay, now switch is closed. Now see the condition. State condition are established. The switch is then opened at t is equal to 0. T equal to 0, switch opened. What does that mean? So in that time your circuit will be equal to this: inductor, resistor, resistor, and resistor, here resistor, inductor. This will be the circuit because now it is opened. So this battery is not at all connected to circuit anymore. This is the condition, and it's like basically your L1, this is 2R, this is L2, 2R, R, and R. Now see, the important point here from this condition to this condition is that because inductors opposes the change in flux, so that's why even when the switch is open, the current through each inductor will not change immediately, is it? That is the main point here actually. So the current through this inductor was earlier I, that was it's I by 2, and that will be still remaining same, and here it's also equal to I by 4. So now what will happen? Total current here it's flowing because it can't go this way, so it will be moving in this direction, and it will be like how much? 3I by 4 current will be going this way, and I by 4 is this, so it will be I by 2 current. So this way current will be flowing in this circuit. Clear? That is the situation. Now it's asking, so the switch is then opened at t is equal to 0, then choose the correctest option for the instant immediately after t is equal to 0. Alright, now this is the situation for immediately after t equal to 0. Let's try to see the option. So current through again I need to check for R1, R2 here option. Okay, so now this is the whole system given. Now let's talk about the options. So here first option it's saying current through R4. So current through R4 is this, and its current is equal to I by 4, and so I can write current through R4 it's equal to I by 4, and that is I is equal to E by 2R, so it will be equal to E by 8R. Is the option matching? It's definitely not. So A is not matching. What about B? Current through R5. Current through R5 is 3I by 4. So current through R5, R5, I will be equal to, you can write 3. So means 3E by 8R. And what is it's giving? E by V by, basically E is V here. Just one second. So this is also not matching. Let's talk about option C. Potential difference across L2. So L2 is this. Now I can apply KVL in this loop. So V across L2, and now I am going from here, then it's like in this direction. So minus 2R multiplied by the current across this, that is equal to R5. This is R5, so this is equal to 3V by 8R, because I am going in the direction of current, and across this minus 2R multiplied by R4. R4 is V by 8R equal to 0. So V L2, it's coming out to be 2 and it's basically 3, RR gets by 4 plus this will be 2, so V by 4, that is V 4V by 4, and that comes out to be V. So this option, yes, it matches, so C is correct option. And next D, so it's a potential difference across L1. So for L1 again I can apply KVL in this loop, so then I can write V L1 minus, this is I by 2, I by 2 is this, I is V by 2R, so this will be like 2R multiplied by V by 4R, minus across this it will be 2R multiplied by R5, R5 here we are getting 3V by 8R, and here also we are going again in the direction of current, so then it will be minus R multiplied by I by 2, I by 2 is V by 4R equal to 0, and we can simplify it and exactly just RR gets cancelled, this is V L1 minus is equal to, this is what, V by 2 plus here it will be like 3V by 4 and plus this is V by 4, so this is equal to 3V by 4, so it's V plus V by 2, that comes out to be 3V by 2, and this is also matching exactly. So this is about problem number 3. I hope you understood. You should like have an idea about that how inductors behave after a long time when they are connected in circuit. Immediately after some change is done in the circuit, how things across the inductors changes, that should be the another point you should be remembering. So across the inductor things doesn't change even when the circuit is disconnected immediately, so that way the current in the circuit will be in this manner, and then it's like basic circuit analysis, you can apply it and you will get the answer. So this is all about question number 3. Next, question number 4. So let me also draw its diagram and all that. Okay, so here see the next problem number 4. Consider the AC circuit shown in the figure and choose the correct options regarding RMS value of potential difference between A and B. So RMS value of VA minus VB, this is it's asking about. So this is the circuit, and let's say the current is flowing in this direction, then I can write I1 it's and I2. So I1 I2 current can be, I1 is equal to what, V0 divided by 2R multiplied by sine of omega t, right? And similarly I can write I2 is equal to V0 divided by Z, and Z is equal to under root XL square plus, let's say the at some moment of time its resistance I am taking, it's equal to either let's say it's simply equal to X, so plus X square multiplied by sine of, and this is what, here it's LR circuit, and in case of LR circuit our current lags behind, so this is omega t minus some phi, and we can write, actually we don't need exactly phi, but still we can write phi tan phi is equal to it will be XL divided by R, basically that is XL. So this is your I2. Now I can write the potential drop VA minus VB, so the current will be going this way, let I am assuming the current at some moment of time at which I am talking about is flowing in this direction, because it will be like changing immediately, so I am just considering sticking to one instant. So at that instant then I can go from here to there, so it will be like VA minus VB is equal to minus I1 into R1, like going in this way you can go VA minus I1 into R, and then it will be opposite to the direction of current, so it's plus I2 into R, that is equal to X equal to VB, and this implies VA minus VB is equal to I2, this is I1 into R minus I2 into X, and then I can substitute, so it comes out to be simply V0 divided by 2 into sine of omega t minus V0 into X divided by under root XL square plus X square into sine of omega t minus phi. So this is the expression of delta V, that is VAB, potential difference across A and B. Now it's talking about the RMS value. Is it? So not about this value. So let's calculate its RMS value. So VAB RMS, this is given by what? Under root integral VAB square into dt 0 to total t divided by integral dt 0 to t. Or now I need to substitute things here, then it will be equal to under root. This I can write simply total t, and this is that 2, it's 2 pi by omega 0 to 2 pi by omega VAB square, so that is V naught by 2 sine omega t minus V naught by under root xl square plus x square into x into sine of omega t minus phi whole square into dt. So this is the actually expression. Now I need to simplify it. Okay, so let's talk about it. Now I will be expanding it by a minus b whole square, then I am getting it, this is equal to under root. Okay, so this is and I'm like solving it further also. So it's V naught integral V naught square by 4 into sine square omega t into dt 0 to t divided by t plus integral, this is V naught square x square divided by under root, this is xl square plus x square into sine square omega t minus phi into dt and divided by t and 0 to t, right? And then it comes basically minus integral, so AB, so then 2AB, so 2 gets cancelled, so this is V naught square into x into r divided by under root xl square in plus x square into sine omega t, and this complete quantity will be under root. So I am writing this next part here. Just try to understand, this space is there less, so I'm writing this quantity will be like minus something will be under root, that quantity I'm writing here, so it's minus, so that will be integral, this is V naught square into r into x divided by under root xl square plus x square into sine of omega t into sine of omega t minus phi into dt, and this whole divided by t 0 to t. So we got it up to here. The calculation is little bit lengthy, just pay attention. This is the system RMS value, this is the final like requirement we want. We got I1 I2 by applying this KVL, like we got VA minus VB and we got finally expression this. Now we need to deal with the RMS value of this. So RMS value of this potential difference will be, this is the formula, and substituting we are getting up to here result. Okay, now let me erase this part and let me simplify that. So now you can see actually if I just look something square into dt 0 to t and 0 to t, so this is exactly that value, and its peak value is given by V naught by 2. So I can write the value after solving this will be equal to actually right. Okay, just one second. Okay, so now on solving this here, the average value of sine square theta is 1 by 2. So then after that I will be getting its complete under root. This comes out to be V naught square by 8 plus. Similarly, I will be getting V naught square into x square divided by xl square, or you can write 2 into xl square plus x square. So we get this value, and minus here I will be getting actually these terms. So it will be like, first let me take it out, V naught square into x divided by under root xl square plus x square, and integral here we have sine omega t into sine of 2 omega t minus phi. that I can write like multiplying by 2 and dividing by 2 to 2 sine omega t sine c sine d, is it? That will be cos of c minus d and plus cos of, okay, it will be like that, I mean like okay, cos alpha minus beta minus cos alpha plus beta, this is equal to 2 sine alpha into sine beta. So alpha is your omega t, beta is omega t minus phi. So that way I can write this quantity is equal to, I can even write it here. So alpha minus beta, then I will be getting cos phi minus cos, it will be equal to omega to omega t, is it, minus phi. So that will be okay. So see it here, this term can be equivalently, this term dt can be written as this. So if I am writing it here, then 2 will be there and this will be cos alpha minus beta, then I will be getting with cos phi only, and minus this is cos of 2 omega t minus phi into dt. Simplifying it further, next step, and 1 by 2, so under root this step v naught square by 8 there plus v naught square x square divided by 2, I can write it also z square, or let me write it xl square plus x square minus, see this is cos phi into, and one more, this t will be still there, so this whole divided by t, because these two parts has been simplified, this is still, so cos phi is constant, so integral of dt divided by divided by t, so integral dt will be t, and you can imagine it's t gets cancelled, so then I will be getting it's v naught square into x divided by 2, this is under root xl square plus x square into cos phi minus it will be plus, this is v naught square x, just try to look at it, and this whole divided by capital T, so this will be v naught square into x divided by 2 under root xl square plus x square into integral cos 2 omega t minus phi into dt divided by t and 0 to t, and integral of this cos function over one complete cycle, it's equal to 0. So we are left in cos phi, so I wrote there actually tan phi is equal to x by that was x, tan phi it was xl divided by x, then cos phi will be equal to x divided by under root xl square plus x square. So if I am substituting it here, then I am getting it under root v naught square by 8 plus v naught square x square divided by 2 xl square plus x square minus v naught square x divided by 2 under root xl square plus x square into cos phi, and cos phi is that same, so it's exactly x square and divided by this whole square, so then I am getting it xl square plus x square. You can see this is negative positive cancelled out, so finally the RMS value is v naught divided by 2 root 2 is the RMS value of VAB RMS. This is our final result, and let's check the options now. So here we were having question number 4. So VAB will increase on increasing R, so it's actually not depending on the value of R, this rheostat resistance. Decrease, that's definitely. VAB does not depends on the value of R, VAB does not depends on the value of omega, so here you can see C and D both are correct option. I hope you understood. The question was a little bit lengthy to solve, to explain you proper step by step. If you are like not going step by step, then you can directly write the things. Actually here I have drawn it, written it properly so that you can understand it completely. So that's why it is appearing a little bit lengthy. I hope you understood this. Let's see the next problem here now. Okay, see next problem number 5. So consider a thick conducting cell of inner radius R1 and outer radius R2. So this is a thick conducting cell, inner radius R1, outer radius R2. As shown in the figure, cell is neutral and point charge Q is kept at center O, like A of the cell, and B and D lies at distance R1, B at R1 and D at R2 as shown in the figure. So then you are asked to find. So Q is placed at center. So what will happen? Some minus Q will appear on this surface, minus Q, and plus Q will appear at the outer surface. This will be the system. So now it's asking potential of point D, a point VD will be equal to what? Potential due to this and this will be 0, so VD will be equal to simply KQ divided by R2. It's matching? It's not matching. B option. Potential of point B, VB will be equal to KQ divided by R2, VB, okay, minus KQ divided by R1 and plus KQ divided by R1. That will be your answer, and it's exactly matching, plus KQ. So B is correct option. And C, potential at point D will change if point charge shifted to position C. So if point charge is shifted to position C, then still, okay, the potential of point D will change. It's not right, it will not change. The potential of B will change if point charge is shifted to position C. Yes, potential of point B, so D is potential of point VB, yes, will change if we are shifting the point charge. Next question number 6. So here it's when an air bubble rises from the bottom of the deep lake to a point just below the, so this is a lake, an air bubble rising from here to just below here. It's moving from in this way. So here definitely pressure outside is high, it will be P outside, it will be like low, so bubble will expand. And what about, so when okay, surface of the all right, so now it's talking about bottom of the deep lake to a point just below the water surface, pressure of the air inside the bubble. So now it's talking about P inside pressure, P inside. So what about P inside pressure? It's talking about, so inside is greater than the pressure outside. That's correct. Inside pressure will be always greater than outside. Correct. That's correct. Is less than the pressure outside in it. No, that's B is not right. Increases as the bubble move up. No, see here, as bubble move up, the outside pressure increases and so on. So the inside pressure, as bubble basically move from here to there, outside pressure decreases, so that's why inside pressure will also decrease. So decreases as the bubble move up. So B and D both are, sorry, A and D are correct options. C and B, it's not right. This is logical simple problem. Question number 7. Probability of decay of particular nuclei of substance Z in next 1 hour. So probability of decay of Z nuclei in next 1 hour. 1 hour, it's given as 1/3. This probability means, if I am saying, let's say N0 is the number of nuclei initially present, and let's say X N0 number of nuclei decayed. Nuclei decayed in that 1 hour, then its probability is X N0 divided by N0 is the probability, and that is given as 1/3 actually. So means after 1 hour 1/3 will be decayed, N0/3 will be decayed, and 2N0/3 will be left. That is the meaning of it. So now let's check it. Then probability of the decay of the nuclei of the same substance. Now it's talking about few cases in the next half hour. So this I can write actually A option in next half hour. So I write here, let's say probability of decay in 1 hour, it's 1 by 3, is it? And here I have taken it x for 1 hour, but it's given actually it's simply straightforward 1 by 3. All right, so let me write, let in 1 by 2 hour the fraction of nuclei decay, let me write it simply f. So then I can write the probability of decay, it's f n naught is the decayed in half hour, and then left is equal to what, 1 minus f multiplied by n naught, and next this many decayed in next half hour divided by total n naught, this should be equal to 1 by 3. I hope you understood this. And then we can solve it. Actually this can be you can solve for f. Okay, so after solving this directly we get f is equal to 1 minus under root 6 by 3. So this is the probability of decay in next half hour. So it's saying simply 1 by root 3. That's not correct option A. B, probability of decay in next 2 hour. So next 2 hour I can write decay in 1 by, like 1 hour it's 1 by 3, next 1 hour it's 1 by 3 of 2 and not by 3. So these many number of nuclei will decay in 2 hours divided by original nuclei, and this is the probability of decay in 2 hours. That comes out to be n naught gets cancelled, it's basically 1 by 3 plus 2 by 9, so it will be basically 5 by 9, and that option matches. So this is B is correct option. Similarly in the next 1 hour it's 1 by 3, in next 1.5 hour definitely D will not be right option, and because in 1 hour it's given 1 by 3, so C will be also not right. So C is also not right and D is also not right. This is about problem number 7. Okay, see next problem number 8. So here one diverging lens is given and one object is moving from minus infinity to O, and then it's talking about the image formation different situations. So to answer this type of problem, it's best is to remember it's V versus U graph. So this graph actually looks like this. It's passing from like V equal to U and this is for this lens. So now when object distance is from minus infinity to U, this is 0, your image distance V is equal to minus F. It's varying from minus F to 0. So now you can check the options. So when object is moving between minus infinity to 2F, its image will be virtual and diminished, that you can see definitely. So image is V is coming out to be, so in this region it's minus infinity to actually 0, minus infinity to 0, and you can say it's virtual and diminished. So definitely from minus infinity to 2f1 also it will be same thing. So A is right option. B, it's talking about when object is moving between 2f1 and f1, its image will be real and diminished. That's definitely, so it will be like 2f1 and f1, it will be somewhere between this, and here also it is diminished and virtual, not real actually. So B is not right. Object is moving between f1 to O, its image will be virtual and enlarged, definitely that is also not right. For condition for combined motion of object, image will be on same side of the, for complete motion of the object, image will be on same side of the lens. So complete motion here mentioned is minus infinity to O, and yes, for this situation this is the motion and image is lying only on same side. So D, C is also not right, and D, yes, it's correct. So straightforward problem based on. And next problem number 9. So consider a planet of mass m and radius r shown in the figure as the particle is projected from the planet theta. Okay, equal. So now it's given. So here it's given this is a planet, and from here at some angle theta it's v naught. V naught is the actually also orbital velocity of circular radius r. So I can write v naught is equal to under root g m divided by r. So the particle is projected with the radius vector and with velocity v naught and at an angle theta with the radius vector. Now it's asking about maximum distance of the particle from the center of the planet. So let's say the velocity is final v, then we can use the conservation of angular momentum. This will be v naught sine theta, this will be v naught cos theta. So definitely in this direction there will be force, and v naught cos theta will keep on decreasing, but I can write conservation of angular momentum v naught sine theta into r should be equal to mv into, let's say, final distance from the center of the planet is r. So then I'm getting v is equal to v naught into r by r into sine theta. So I got relation 1. Another, I can use conservation of energy principle. So from there I can write half m v naught square minus g m divided by r equal to half m v square minus g m divided by r. V is this, substituting and solving it, actually we get r is equal to r plus r cos theta. You simplify it, so that's correct answer actually. So A is right option. Yes, this is the maximum distance from the center of the planet. And another thing is, it will be like the motion will not be a parabola, because here orbital velocity, the velocity is not equal to escape velocity, it's less than escape velocity. So definitely the particle will not escape the field of this planet, so the path will not be a parabola, and it will be sort of like an ellipse. Path will be an ellipse. In that case, its time period will be proportional to, like, you can write under root r cube, major semi-major axis, is it a cube? So I can write t will be equal to something 2 pi under root r is r plus r cos theta whole cube divided by gm. So based on that, your C and D option is also not right, so only A is correct, right? This is problem number 9. Next, problem number 10. So here it's mentioned about the measurement of G value. One experimental setup is given for problem number 10, and the data given to you. Suppose a student measure the G acceleration due to gravity by measuring the time period of the stone to fall from height h of the ground, and after making the several concluded. So this is given actually. So the T value, this is question number 10. T is given 1.6 plus minus 0.1 second. H is measured as 46.2 plus minus 0.3 feet, and the G relation is given as 2h divided by t square. So now you are asked to find the percentage error in T, H and G and so on. So delta T by T into 100, that will be 0.1 divided by 1.6 multiplied by 100, it comes out to be 6.25 percentage in delta T. Delta H divided by H into 100, that will be equal to 0.3 divided by 46.3 multiplied by 100, it comes 0.6 actually, yes, percentage. And then delta G divided by G, by taking log, it will be equal to 2 delta T divided by T plus delta H divided by H, and that is equal to 2 into 6.25 plus 0.6, and this comes out to be 13.1 percentage. So C is correct option and A is correct option, and this B is 6.3, that's not right actually, I mean like according to the option. And D, solving it, the value of G will be 36. This 13.1% will be equal to plus minus 5 feet per second square. So D is also your right option. So it's your answer is A, and C and D should be correct option. This is about problem number 10. Okay, next it's section 2, numerical value type questions, and question number 1, it's a straightforward problem here. Original frequency is given as 440 hertz, and here source is there, and observer is moving with some velocity, and speed of sound is 340 meter per second, and the observed frequency f prime is given as, that is 462. So here f prime is equal to f naught into v plus v observer divided by v, and this is 462 equal to 440. This is 340 plus V divided by 340. Solving this, we will get 17 meter per second. It's straightforward problem. Next, question number 2. So here 3 particles are there. One is Q1, Q2 and Q3. This is 1 coulomb, this is 2 coulomb, and this is given as 4 coulomb. So we have 3 particles having different charges, and they are placed at different locations in so that the force between 1 and 2 it's given as 8 Newton. Between 2 and 3 it's given as 16 Newton. So it means some separation will be there. So 8 Newton can be written as K, Q1, Q2. So this is 2Q divided by some D12 square. This implies D12 is equal to under root K divided by 4. Similarly, 16 is equal to what? This is this into this. So it's 8K divided by D23 square. This implies D23 is equal to under root K by 2 separation. Now it is asking what should be the what will be the minimum value of the force between 1 and 3. So minimum value of the force between 1 and 3 will be there when the separation between these 1 and 3 will be maximum. So separation between these two is this, these two is this. So if these two are added, that will be the maximum possible separation. So that in that situation force will be minimum. So the minimum force F minimum will be equal to K1 into it is 4 divided by this is D12 plus D123 whole square. So substituting all these values, we get F minimum here actually comes out to be it's 2.745 Newton. Check the calculation here. Answer it's given is different actually. So question number 3. So the diagram below shows schematically 2 situations dealing with the homogeneous aluminum sphere of radius. So here all those data is given and 2 situations are described actually. You can see we are measuring the weights actually, and 2 weighing machines are placed. So in situation 1 actually the stand is placed on a weighing machine, and the beaker basically and this support both are in air actually. So whatever the tension is passing to the stand, tension and that weight of the stand will be actually the reading of case A, and similarly in case of B it will be the complete reading. So if we look at it and draw the write the values, then it comes actually the mass in case of A is equal to mass of stand, that is D, plus mass of basically here this is beaker sphere. So this is on weighing machine. So this is the machine. So this mass of stand plus whatever the tension here, this will be also passed here, and this will be equal to what? Its weight mg minus buoyancy force. So that will be equal to basically its volume of the sphere is, let's say, Vs multiplied by rho Al, its mass minus rho water. So this is Ma. Next case Mb will be where in case of Mb this is also placed, and this is a sphere, this, and complete setup is placed on weighing machine. So now it will be measuring the water, mass of the water, mass of the sphere and stand and everything actually here. So it will be mass of stand, mass of water. So mass of water will be volume, density of water into volume. Volume is pi r square into h minus volume of sphere. This mass of water plus mass of sphere, that is equal to rho Al into volume of sphere, and mass of this what else mass is given, d mass of sphere, and here we are given with mass of this m, and one more term is there, cylindrical flask. So that is equal to m, n is the mass of the flask. So this will be the reading of in case of A, this will be the reading in case of B, and now it's asking m b minus ma. Just simply substituting this, it will be simply getting cancelled. Rho Al into Vs, so this term will get cancelled, and rho water into Vs, this term will also get cancelled, and we are left with this and that, so it's be equal to mn plus this is rho water into pi r square multiplied by h. Now simply substituting the values, this is your delta m, and substituting the value you will, and solving, you will get 500 gram will be the answer for your problem number 3. So solving and substituting, you will get that comes out to be 500. Okay, see next problem number 4. So this is the circuit diagram given for situation 4, and you are asked to find the R equivalent between A and B. Now see, just look at this diagram actually. So here whatever the potential is there, this is a complete wire, so same potential, and same potential it's connected to here. So now you can see these 2 points are having same potential, means this complete circuit is what? Short circuited. So when it is short circuited, no resistance of this will be acting here. So actually this circuit is equivalent to simply this capital R, this is small r, and this is the circuit, because remaining here all is 0. So small r, capital R, and these are your points A and B. Then RAB is simply these two in parallel, small r plus capital R. Substituting the values, this is 12 into 8 divided by 20, and this comes out to be 4.8 ohm. This is your answer for question number 4. Next, question number 5. Using the dimensional analysis, angular frequency omega of the surface wave. So omega we are supposed to find by dimensional frequency. It's depending on few parameters: surface density sigma, water density, and wave number k. Wavelength is derived. Okay, you assuming the dimensionless coefficient of like dimensionless coefficient is equal to 2, then okay, so we can write omega will be like directly proportional to some sigma power alpha, omega directly proportional to q power beta, and directly proportional to k power gamma. And this proportionality constant, I can write omega is proportional constant 2, and this is sigma alpha q beta gamma, and this is k gamma. So this way, and then we can substitute sigma is what? Surface tension, q is density. So this comes out to be omega dimensionally. Omega, this is surface tension, m t minus 2 surface tension into 2 power alpha, q density, m l minus 3 power beta, and this k wave number, so this is l minus 1 power gamma, right? This, and finally, and omega, this will be equal to simply t power minus 1. Just simply simplifying and equating the exponents power on both sides and solving for alpha and beta, we are getting alpha is equal to 1 by 2, beta is equal to minus 1 by 2, and gamma is equal to 3 by 2. So just substituting there, then we are having omega is equal to 2 under root, this is a sigma into q is minus, so sigma k power 3 divided by q, this is your like omega finally, and then yes, k beta power minus half, then d omega by dk differentiating, so this is under root sigma by q is constant, this is k power 3 by 2, so 2 gets cancelled, it's 3, and k power 3 by 2 minus 1, then it will be also coming under like this. So this is the value, and like here you are given the values of sigma, q, and lambda, everything is given, so you can get the value of k, and substituting, then this is given like it's asking about the value velocity vz. So substituting and solving, then you will get vg is coming out to be 0.6 meter per second. This is your problem number 5. Next, question number 6. It's good problem again, so let's me just erase this part first. Okay, so let's see question number 6 here. In the circuit shown below, we first put the switch on and wait for the current to come to steady state. So let's talk about, so first switch is on and the system we are waiting till it is reaching steady state. So what will be the condition of system in steady state? First thing is, in steady state the capacitors are fully charged, so there will be no current across them, it will be completely blocked. Inductors will act like simple wires, so now you can see actually there will be no current in this arm and infinite resistance, so this no current will be there, and it will be simple wire, so current will be flowing only in this arm. This way current will be flowing, and we can write that current I. So I is given by E divided by R2, correct? And remember that this current will be across inductor this and this. So if I'm writing it's L1 and L2, so current across both L1 and L2 will be equal to E by R2. Remember that. Now this is the situation initially. Now it is saying then we put the switch off. So now switch is off. Is it? Switch off. After that what will happen actually? This circuit is simply gone. Next thing, here current will not change, so this is gone. So your circuit will be like simply equal to, this is a R1 capacitor, this, and here inductor, resistor and inductor, and here it's voltmeter. This is R2, this is R1 and another capacitor, like this. Now see here, because this inductor L2 and current is this, that is E by R2, so this current across the inductor doesn't change, and this current can't flow in this arm actually, is it? And another thing is this current here actually also will be like E by R2 across this, so means we can say there will be one current this way and there will be another current this way actually. Then in this arm, like current will be flowing this way and that way. So now the potential drop across these two terminal, if I take A and B, that will be the reading of voltmeter. So VA minus VA minus, if I am going in the direction opposite to the current, then it will be minus E by R2 into R1, basically plus, and this in the direction of current, so E by R2 into R2, this whole, and equal to VB. So this implies VA minus VB is the voltmeter reading, and this comes out to be magnitude of E R1 by R2 minus E, and this comes out to be solving VA minus VB is equal to simply 3E, and that is equal to 3.75 volt. This is your answer for question number 6. Okay, see next question number 7, and here consider a neutron beam where every neutron in the beam has a kinetic energy. So every neutron in the beam has a kinetic energy of 0.05 electron volt. This is the kinetic energy of the neutron, and take the half-life and the rest energy. So T half-life of the neutron is given as 900 ln2, and its rest mass energy mn into c square is given as 810 mega electron volt. This is the information given respectively. Find the fraction of the number of neutron which will decay before the beam travel a distance of 10 meter. Beam travel a distance of 10 meters. So by this time, fraction of nuclei that will, fraction of neutron that will decay, and that is a problem it's asked. So basically this is a beam traveling, and this distance traveling is given as 10 meter. Its kinetic energy is this, then this kinetic energy can be written as half EK, I mean like kinetic energy equal to half mass of neutron into V square. So we get V is equal to what? Under root 2 EK divided by mass of neutron. This is the velocity. How much time it will take to travel? Time to travel, that can be written as basically D divided by D is D divided by V, and D is 10 meter, V is this. So this comes out to be D under root M divided by 2 EK. This is the time. Now if N is the number of nuclei, number of neutrons initially, then fraction of the neutrons decayed in this time can be written as actually N is equal to N naught e raised to power minus lambda into T, right? And what is lambda? Lambda can be written as ln 2 divided by T half, and that will be equal to simply ln T half is given as, okay, so this is your lambda, right? Then I can substitute it here. So this comes out to be N is equal to N naught e raised to power minus ln 2 divided by T half multiplied by T. T is equal to D under root M divided by 2ek. This is the number of nuclei left. Now it's asking about the fraction of nuclei decayed. So that will be equal to fraction of number of nuclei. This is n naught minus n divided by n naught. This is the fraction of nuclei decayed. Substituting these values, this will comes out to be n naught minus n naught e raised to power minus lambda t divided by n naught. This comes out to be simply 1 minus e raised to power minus lambda t. This is 1 minus e raised to power minus lambda is ln 2 divided by t half multiplied by, this is d under root m divided by 2ek. So this, and now it's complete term, this can be taken as some x. So then it's like we have one infinite series expansion of Taylor series, 1 plus x divided by 1 factorial, x square by 2 factorial, and so on. When this x quantity is very small, so we neglect all the higher power, and this is equal to that. So similarly, like substituting, simplifying it, it will be 1 minus 1 minus minus, it will be plus x, that will be equal to ln 2 divided by t half multiplied by d under root m divided by 2ek. So 1 gets cancelled, so the fraction is coming out to be this. So this is ln 2 divided by t half is 900 into ln 2 multiplied by d multiplied by m divided by 2ek. Now you can substitute all the values here, and simplifying we get fraction is coming out to be 10 by 3 into 10 raised to power minus 6. So according to the expression given, x is equal to 10 by 3. This is your answer. That will be 3.33 or 3.34. So this is about problem number 7. Okay, see next question number 8. A proton with invariant mass of proton is given, and its kinetic energy is given, hits a nuclei of isotope lithium with the mass of 7 mu and induces a decay to 2 non-excited alpha particle with invariant mass. So everything is given. So here what is given? 1 neutron plus this is Li, and it is also having some kinetic energy, and this ultimately decaying some 2 alpha particle and some kinetic energy of alpha particle. This is kinetic energy of neutron. So this is what exactly happening. So we are asked to find this. So here conservation of energy can be applied. So conservation of energy, so that will be kinetic energy of neutron plus rest mass energy, that is mass of neutron into c square, plus 7 mu mass of lithium into c square. This is equal to 2 times mass of alpha into c square plus kinetic energy, total kinetic energy of alpha particle. So then you can simply write k alpha is equal to k neutron kinetic energy m and c square 7 mu into c square minus 2 m alpha into c square, and this k n plus m neutron plus 7 mu minus 2 m alpha whole multiplied by c square. Now everything is given to you, k alpha, just substitute the values and solving, we are getting k alpha is coming out to be 3.418 MeV. So this is your answer for problem number 8. Next remaining section number 3, section 3rd, and where we have basically in section 3rd some integer value type problems, and let's talk about. So first here we have question number 1. Here question number 1, consider a book lying on the floor and studying. So here a book is lying on the floor like this, and a force is acting on it, and such that this is basically here, so whose length lying on a book, and a string with the length, so this string with length 2 meter and height this is 1.2 meter, it's pulling, and this is the theta. So basically this string is pulling, applying some force. What will happen? Friction coefficient mu into normal reaction. So here its weight is given 10 Newton and its normal reaction, and this is the situation. And the condition is book is moving with constant velocity. with constant velocity. So means net force on the book must be 0. So first thing is I can calculate sine theta is equal to 1.2 divided by 2, and that is 3 by 5, that is 37 degree. Now I can write actually here f sine theta plus neutron n should be equal to 10, and f here it's given force, how much force we are applying. Force is given 10 Newton, and theta we know at all when we are getting solving, n is coming out to be 4 Newton. Next thing is f cos theta plus f cos theta should be equal to mu times normal reaction, right? Here f cos theta should be equal to normal, and here f we know 10, cos theta we know, and normal reaction mu into 4. Simplifying mu we are getting it's 2. So it's asking here exactly neglect the, okay, if your answer, okay, this find the coefficient of friction between the block and the, so coefficient of friction is coming out to be 2, so the answer is 2 for question number 1 for section 3. Next, last question. Okay, next, that is question number 8, question number 2, section 3. So here there is one policeman and another is robber. So let's say it's robber, and here we have one policeman, and they are in a dark town like hall which is 100-meter like separated, and there exists some potential difference delta, that is potential difference is given 144 voltage, and this is 8-meter height. So the electric field between this like E can be written as U divided by D, that is 144 divided by 8. This is the electric field voltmeter. And now what is happening, the person is firing bullet from here, so this is at height 2 meter, and it's acquiring some charge Q, and let's say the mass of the bullet is m. So now what is happening, like he's firing, and the condition it is asking is what should be the least Q by m ratio, so that the bullet before striking the policeman should strike the ground. So means the motion of the bullet should be something like this, it should strike this way. So here net like on the bullet downward force will be mg and plus qe, right? So I can write the acceleration of the bullet will be equal to g plus this will be qe divided by m. This will be the acceleration of bullet downward, and then vertical velocity in the component of velocity in the vertical direction, initially it is 0 and distance this much. So let's say right, this is h, then I can write h is equal to what? H is equal to half into, let me write this is a, so a into t square. So this t is coming out to be under root 2h by a. Now by this time it should cover just distance that is equal to 100 meters. So I can write 100 meters should be equal to, that is its muzzle velocity multiplied by t, and this is given 400 actually, and t is this, so substituting it's under root 2h by a, and 100, and this is 400 multiplied by under root 2h is 2 divided by a is g plus this is q by m into e. E is given as 144 divided by 8. So this is the relation, and here only q by m is unknown. We can simplify it, and solving this relation we get the value of q by m, and it comes out to be 3 coulomb per kg, and this is the answer for the last problem, that is question number 2. So this was all about your paper. I hope you understood. You just go through this part, and I hope like this should answer your doubt, whatever the problem you are having in any question. And that's all. Thank you so much. See you next.